Hey guys, today we're going to look at a problem from Leetcode Weekly Contest 218. This one is called concatenation of consecutive binary numbers. So given an integer n, you need to return the decimal value of the binary string formed by concatenating the binary representations of 1 to n in order. Return this in modulo of 10 raised to 9 plus 7. So you see this modulo thing in problems where answers can be really huge. Once you do this modulo operation, what it does is that it makes sure to wrap around the integer value within 10 raised to 9 plus 7. So you can handle bigger cases as well. So let's get into our problem. What does this mean? If we get n as 3, let's take the binary representations from 1 to 3. Binary representation of 1 is 1, of 2 is 1 0, and 3 is 1 1. Concatenating these, you will get 1 1 0 1 1. Now we need to convert this longer binary string in decimal format. This binary string is basically 27 in decimal system, so we just need to return that. To convert a binary to decimal, we take each digit from the least significant to the most significant and multiply incrementing powers of 2 with each digit and add them all together. It may sound a bit too much, but this is all we are doing. So in this case, multiply 1 with 2 raised to 0 plus 1 times 2 raised to 1 plus 0 times 2 raised to 2 plus 1 times 2 raised to 3 plus 1 times 2 raised to 4. Add them all up and we get 27. For this problem, we also need to know the properties of a modulo operation. Mainly, you need to understand this particular property to solve these kind of problems, but we'll get to how we can use that later. To solve this, we could create a binary string by converting all of the n numbers to their binary equivalent. But we don't really need to do that. We know that n will be the last binary string and lesser numbers will be towards the left in the binary string. So we can simply iterate from n to 1. Now let's put the current number into a variable bin. We'll keep track of the variable ans as 0. This is for keeping the value of the sum of multiplication of powers, this whole thing. We'll also keep a variable POW, which will keep the current value of power. So this will keep the value 2 raised to 0 initially, which is 1, then 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on at later points. Before we do the next part, we need to understand a couple of things. Number 1, checking if the last bit of a number is 1. To check this, we could use the bitwise AND operation. If this returns 0, last bit is not 1. If this returns 1, then the last bit is 1. Remember, we don't need to convert an integer to binary to do this. How to consider the second last bits or the consecutive bits to the left? We have a bitwise operation called right shift. If you have a binary string like 11011, which is 27 in binary, if you do right shift on this, we'll get 1101. If we do right shift again, we get 110. Again, and we'll get 11. Next time, we'll get 1. Next time, we'll get 0. We can combine these two techniques to our advantage in this problem. First, we can check if the last bit of the bin variable is 1. If it is, then we can add the current power value to the answer variable. Next, we need the next last bit. For this, we can simply right shift bin by 1. Now we need to update the value of POW. If you notice here, we can see that the POW is multiplied by 2 each time. So we can do that in our code as well. We should be doing this till we go through the entire bits in our current number. So we can do this while bin is greater than 0. Ultimately, we can return ans. But now we have a problem. If we try and input like 12, we'll get a negative value in the answer, which suggests that there's been an integer overflow. This just means that the value is greater than what can be handled by the integer type. In the problem, it is given that we need to return the answer modulo 10 raised to 9. First, we'll keep a value 10 raised to 9 in an integer. Now we need to look at the points in our program where we could be having an integer overflow. 2 points are when we are updating the ans value here and also when we are updating the POW value here. All we need to do is to take mod at these points. Now if we try and submit this, we'll get an accepted solution. This program now works for bigger values of n as well. Just to recap, we discussed how to check if the last bit is a 0 or 1. How to iterate from the last bit to the first bit of a number, how to convert a binary string to a decimal, and how to use modulo 10 raised to 9 in your solutions. Use these techniques to your advantage in future competitions. I hope you enjoyed this video. If you did, please consider subscribing. See you soon.